Welcome back to the SQL Sandbox. Before we started working on regression to the mean, I wanted to show you one command which you might find useful. It's the describe command, and it helps describe tables within the database. So I have here describe teams. We put that in our SQL Sandbox, run that code, and the result we get describes the fields within that table. So we did teams, and we have year ID, league ID, team ID. We list all the field names in that table. We give it the variable type that it is, string, character, integer. We also indicate which of the field names are the keys. That's represented here. These are the primary keys to the team's table. Year ID, league ID, team ID. The combination of those three things is a unique identifier for every record in that table. Tuck away the describe table command for your future use as needed to learn more about the tables inside the SQL Sandbox. Next, I want to run another query that's going to help us understand better regression to the mean. This is a long query. I'll describe it in a second, but first let's run it and see what kind of result we get. Here's the result. Remember the question I left you with in the last video segment. I asked you if there'd be a drop-off from the top 10 players by OPS in 2012 when we looked at their 2013 OPS. So I just ran a query that gave us records of descending order for the 2012 OPS variable. So Joey Votto had the top OPS in 2012. He went down. That might be random, or it might be real, might be regression to the mean. But looking at all the 10 players who were the top 10 performers by OPS in 2012, 8 of them go down. The only 2 that go up are Miguel Cabrera and Mike Trout. Here's Miguel Cabrera's numbers. He goes up from 999 to 1078. And Mike Trout goes from 963 to 988. So he goes up as well. Now these are all great baseball players. And being at the top of the OPS list represents their skill level, their talent level. But also, even these great players had some good fortune during 2012. And maybe that good fortune was wearing off in 2013. This is the classic representation of regression to the mean. So let's look at this query. There's a few different things going on here than we've described before, and it might be helpful for your future SQL Sandbox work. First, I want to download the results so I can use them in RStudio. So I click here. And now let's talk about this SQL query. The top part here is our select. And what we're selecting is player ID and team ID, but we have a new qualifier at the start, B12. Now where does the B12 come from? It comes from batting. It comes from the batting table. So we've described B12 as an alias for the batting table, one representation of the batting table. But we've also done it for B13, and you'll see why in a second. So the first 2 columns in my results table will be the player ID, team ID. These will be the same for either of the batting tables that we represent as B12 and B13. So we take B12, player ID, and team ID. Then we have the next column is PA12. So we set up this formula to represent PA12. Now you should recognize the classic plate appearance formula: at-bats, walks, hits by pitch, sacrifice flies, and sacrifice hits. Each of these terms has the B12 prefix, indicating it comes from the B12 batting table. We also do the same thing for OPS 12. Very similar. We put the B12 prefix on each of the variables to create OPS 12. Now these 3 lines here of code are exactly the same as the 3 above, except it says 13. So we create PA13 and OPS13, two new columns in our results table. And all the prefixes for these two new columns have B13 on them. We want to calculate the 2013 plate appearances and the 2013 OPS and put them in new columns right next to the 2012 plate appearances and the 2012 OPS. We take them from two instances of the same table. Now in the where clause, we want to make sure that for each of the results in our table, the player ID is the same. We want Joey Votto's OPS to be the same for 2012 and 2013, so we put this as a where clause condition. We want each row to be the same player. And we want to make sure when we do the work for B12, it equals 2012, and B13 equals 2013. So we only take results from these years. We also put another qualifier on here that, and we use the having command for that because it's not a field name within the table batting. We created a new field name for our results table. We use the having command to do that. We make sure that all the plate appearances for both years are greater than 100 plate appearances. Then we order the results table by descending OPS from 2012. So you should be able to understand this. We added this other interesting wrinkle to use two instances of the batting table in our conditions. And we have two different results from two different years in this batting table as well. Again, here's our results table. I've downloaded it onto my desktop, and now we're going to upload it into our studio and work on it from there.